Hello friends, in this video today we are going to discuss about particle in 1D infinite square well potential, which is asymmetric, that means not symmetric. Okay, so in the next video we are going to discuss about symmetric box. Okay, so let's start now. Suppose let us assume that this is a square well potential, 1D square well potential. So this is x-axis. So let us consider a particle inside it. So and as this is infinite square well potential, so this particle cannot exit this well. Okay, so we cannot find the particle outside the box. It cannot exist outside. Okay, so this point is, suppose x is equal to a and 0. This is the origin, and here x is equal to a, suppose. And so now you see the potential inside the box, Vx inside the box is 0. Suppose inside the box for x greater than 0 and less than a, so Vx is 0 at this. Okay, and also now at x less than equal to 0 and x greater than equal to a, this wave function associated with the particle, this psi of x, that's going to be equal to 0, because the probability of getting the particle outside the box is 0. Okay, so that's why as we have considered that its depth is infinite. Okay, as it is infinite square well potential. So now you see the Schrodinger equation, time independent Schrodinger equation of this particle. We know the time independent Schrodinger equation is given by it is given by minus a square by twice m second order derivative psi with respect to x plus v psi is equal to e psi. So here you see, as inside this box v is 0, that's why this term gonna be equal to 0, this term equal to gonna be 0. So that's why our equation, this Schrodinger equation, is reduced to minus a square by twice m d square psi by dx square is equal to e psi, as at x greater than 0 and less than a, v of x is 0. So hope you have understood this. Now here E is nothing but E represents total energy. Now you can simplify this equation in this form, that second order derivative of psi with respect to x plus twice m e by h cut square psi is equal to 0. Okay, now here you see this portion, let us consider this is equal to k square. Okay, so let us consider, if you consider this is equal to k square, then what you're gonna have, so second order derivative of psi with respect to x, so then you will get k square e is equal to, sorry, not e, k square psi, that's psi is equal to 0. So where k square is equal to 2m e by h cut square, so which implies k is equal to root over twice m e by h cut square. Okay, so let it be equation number 1, this one suppose equation number 1, and this is suppose equation number 2. So now what you can see from here, this equation, this is a simple harmonic oscillation equation. So that's why its solution should be like this. So solution of this is suppose, so instead of writing here equation number 1, sorry, so let us give this equation as equation number 1. This is suppose equation number 1. This one is equation number 1. So solution of equation 1 will be given by psi of x is equal to a sine kx plus b cos kx, where a and b are constants. Now if you apply the boundary conditions, so if you apply the boundary conditions, let me scroll down the page. Okay, so here is the potential well, and this is 0, this is a. So here this is infinite square well potential, so particle cannot go outside the box, so it confined in this box, so it can exist within this range only, x greater than 0 less than a. Okay, so at x is equal to a and x equal to 0, it cannot exist, and it cannot exist outside as well. So we will get phi of 0 will be equal to 0. So from this equation, so what you will have, you're going to have phi 0 will be a sine k into 0 means sine 0, and plus b cos k into kx. If x is replaced by 0, then cos 0 you will get, that is equal to 0. So sine 0 is 0, so this term going to be 0, so we get only b. So cos 0 is 1, so b is equal to 0. Now let us put this value here. So therefore, suppose let me give an equation number here. This is equation number suppose 3. So from equation number 3, what we will get after putting this value of b here, we will get psi of x is equal to a sine kx. Now another condition, at x is equal to a also, this particle cannot exist, so that's why, let me scroll down, that's why psi of a is also equal to 0. So using if so what will be psi of a from this equation? So you will get a sine k a is equal to 0. So here you see, either in this case either a is equal to 0 or sine k a is equal to 0, if product of these two is equal to 0, but a cannot be equal to 0, otherwise there will be no solution. Okay, a cannot be equal to 0, so we can take only sine k is equal to 0. Okay, now here you see, what is the solution for sine x is equal to 0 or sine theta equal to 0? That is sine n pi. Sine n pi will be equal to 0, where n is what? N is 0, 1, 2, 3, dot, dot, dot. That means it must be multiple of pi, then it will be 0. But here you see, we cannot take, we cannot take n is equal to 0. So we cannot take n equal to 0. So in this case we will consider that n is equal to 1, 2, 3 and so on. Why we cannot choose n is equal to 0, I will explain it later. Okay, just remember it that we cannot take n equal to 0. Okay, now here we see, so if sine of ka is equal to 0 and sine n pi that's equal to also 0, so we can say ka is equal to n pi, right? Ka is equal to n pi. So if ka is equal to n pi, so k must be equal to n pi a. Okay, so now here you can see, if you take k equal to n pi a, so let's move on to the from equation 2 you can see clearly k is equal to this term. So let us put here, so root over 2m e by h cut square. Let us put this value of k here in this equation that we have got now. So what we have, k is equal to twice m e by h cut square. So that's what we have, n pi a. So from here, if you simplify this equation for energy, then what you will get, so squaring both sides and after simplification, so you will get n square pi square h cut square by twice m a square. So here you see, if you take n equal to 0, then this energy is going to be 0. That's why we cannot take n equal to 0 here. So that's why we should take n is equal to 1, 2, 3, so on. Okay, because you know the particle inside the box must have some energy. Okay, so here you see, this is the expression for energy, and so this expression for nth level, it can be written in this form, En, you can write as En. Okay, pi square, this is the general form, a general expression for energy of nth level. So okay, so now you see what will be the lowest energy level. If you find the ground state energy level at ground state, lowest energy level, if you put n is equal to 1, then E1 will be equal to pi square h cut square by twice m a. Okay, so similarly, if you put E2 is equal to, then you will get 4 pi square h cut square by twice m a square. So here, this part here, you see this part is nothing but equal to E1, isn't it? So you can write 4 into E1. 4 into E1 means 2 square E1. So similarly, you can find E3 as 3 square into E1. Similarly, you can find E4 as 4 square into E1, and so on. So hope you have understood this. So that means we can express a general form, that is En is equal to n square into E1. So hope you have understood this. So if you draw a graph, if you represent the energy level graphically, so if you draw the energy level diagram, so this is ground state, this is suppose 0 level, sorry, this is the ground state, E1, lowest energy level, where n is equal to 1, and next one will be for n equal to 2, that's going to be E2, which is equal to 2 square into E1. And here, so for the next energy level, this gap will be increased. So here it is suppose for n is equal to 3, so this is E3, which is equal to 3 square E1. So as you see, this is 2 square times E1. In this case, it is E2 is 2 square times E1, and it is 3 square times E1. So that's why the gap between these two levels must be smaller than these two levels. Okay, so here this gap between 3 and 2 must be bigger than between 2 and 1. Okay, so that's how we can draw the energy level diagram. So now here you see one more thing, that it is sure that we can find a particle inside this box, as it is infinite square well potential. So it is a certain event that particle always gonna be inside this box. So that's why it must satisfy the wave function, must satisfy the normalization condition, which is given by 0 to a phi. Before that, let me obtain the psi first. Okay, so here you see, as we have already written here, psi x is equal to a sine kx, isn't it? We have already written this. So we have got that k is equal to n pi a. Let us put this here in this equation. Let us put this here. So suppose this is equation number 4. Let us assign as equation number 4. So from equation number 4, so equation number 4 implies that psi is equal to, psi of x is equal to a sine, instead of k we will write n pi by a and x. Okay, so we got this. So this is psi of x. Now it must satisfy the normalization condition, so that's why here we are going to write psi of x square, this is a probability density term, dx is equal to 1. It must be equal to 1. So now let us put what is psi of x. So that is nothing but a sine n pi x by a. So here it's gonna be whole square, dx is equal to 1, and which can be written as a square integration 0 to a sine square n pi x by a dx is equal to 1. So here I will show the integration. That so this is the integration of this. So here you see how to integrate. So what formula that I have used here in this system I have written here, so that you can understand easily. And after integrating these two terms we have got this result. Now let us use this, put these limits. So and doing so, what we will get, the result we will get is a square small a by 2 is equal to 1, and which will imply a is equal to root over twice 2 by a, sorry, 2 by a. Okay, so we get this. So therefore the sine of x, it becomes, if you put this value of a here, if you put this value of here a here, then what you will get, psi of x is 2 by a, root over 2 by a sine n pi x by a. So here you see, this is the normalized wave function. So we can in general we can write as psi n x. So n means nth level. Okay, so this is the normalized wave function. Okay, normalized wave function. Now so if we represent graphically, so here you see, so let me show you the graphical representation of this. So if you draw the graphical representation, you're gonna have such kind of graph. Here n is equal to 1, so and this is the ground state, this is first excited state, n is equal to 2, and here this is psi 3, n is equal to 3, this is second excited state. So now you see, for the first excited state n is equal to 1, the what will be the minimum value of psi. So here you see, minimum value of psi is 0, isn't it? Minimum value of psi is 0. So for that purpose we have to take sine pi x, here n is 1, so pi x by a, and it's going to be value of minimum value of sine is sine 0, so that's going to be the minimum. So here n pi x by a, that's going to be 0, so x equal to 0 here. So x equal to 0, here is the point, and maximum, that psi will be 1. So for that case we know sine 90 is 1, so sine pi x by a, so sine pi by 2. So here this this will imply that x is equal to a by 2. So here is the point, we will get the maximum a by 2. So similarly, from putting n is equal to 2, we will get those maximum and minimum for the first excited state. That means the n is equal to 2 here. These points are called node. Remember, this point is node, and this point, these 2 points are antinodes. Okay, so remember that. Now here you see, in this case, if you find the maximum and minimum, you will get for maximum you will get x is equal to a by 4. So here this point is a by 4, and this is twice a by 4. That means you can say a by 2, and this point is thrice a by 4, and this point is a again. So similarly, putting n equal to 3, so here you will get this is a by 6, and this is twice a by 6, and this point here it gonna be thrice a by 6. That means a by 2. Okay, so again this is gonna be 4 a by 6, and this is 5 a by 6, and here it is again a. So hope you have understood. That's how you can draw the graph. So now this is all about asymmetric 1D box. So in the next video we're going to discuss about symmetric symmetric 1D box, infinite square well, symmetric infinite square well potential. So that's enough for today. So thank you for watching. If you are new to my channel, please do subscribe the channel and help me to grow my channel. Thank you for